A square column 500 mm by 500 mm in section carries an axial load of 1500 kilonewtons. Design the square footing for the column. The safe bearing capacity of the soil is 225 kilonewtons per square meter. Use M20 concrete and Fa 415 steel. Design steps of isolated footings. 1. Area of footing required. Let dimensions of column section equals B by B. Dimensions of footing at the base equals L by L. Load on column including weight of column equals W. Self weight of footing equals W dash. Take W dash equals W upon 10. Safe bearing capacity of soil equals P dash. So, side of foundation L. L equals square root W plus W dash upon P dash. 2. Net uplift pressure of soil. P equals W upon L squared. Here the self-weight of footing is kept out of calculation. 3. Depth of footing. Depth of footing can be calculated with 1. From bending moment consideration. 2. From punching shear consideration. Let us first calculate depth of footing from bending moment consideration. As we know, the critical section for maximum bending moment is at the face of column. Maximum bending moment equals M. M equals P into L. Into L minus B by 2. Into L minus B by 4. M equals P into L. Into L minus B whole squared by 8. Factored bending moment Mu. Mu equals 1.5 times M. So, effective depth D for balanced section equals square root of whole M U upon 0.36 into FCK into B into XU limiting by D into 1 minus 0.42 into XU limiting by D. Increase the value of depth by 30% to accommodate shear stresses. From punching shear consideration. Let D be the total depth of footing. Load causing punching shear. WP. WP equals W by L squared. Into L squared minus B squared. Factored punching load. WPU. WPU equals 1.5 times WP. Let the design punching stress equals Q. Equating punching resistance to punching load. Q into 4 times B into D equals WPU. D equals WPU upon 4 into B into Q. Check for shear. 1. For one-way shear. The critical section is a vertical section taken at a distance equal to effective depth from the face of the column. Let us first calculate dimensions of cut section of footings. B dash equals width of the footing at the top. At the critical section, B dash equals B plus 2 times D. assuming angle of slope equal to 45 degree. D dash equals total depth at this critical section. D dash equals D1 minus, in bracket, D1 minus D2 upon 1/2 into L minus B multiplied with D. So, effective depth equals D dash minus clear cover CC minus 5/2. Shear force at this section. B equals P into L into, in bracket, L minus B upon 2 minus D. Factor shear Vu equals 1.5 times V. Nominal shear stress at this critical section equals tau V equals Bu upon V dash into D dash, where tau V shall not exceed the design shear strength tau C. Two-way shear. Two-way shear means the total shear on the perimeter surrounding the column at a distance of half the effective depth from the face of the column. Let D dash be the total depth of footing at critical section. Let us first calculate dimensions of cut section of footings. B dash equals critical width of the footing at the top. At the critical section, B dash equals B plus 2 into D by 2. Assuming slope angle of footing equal to 45 degree. So width B dash equals B plus D. D dash equals total depth at this critical section. D dash equals D1 minus, in bracket, D1 minus D2 upon 1/2 into L minus B multiplied with D by 2. So, effective depth equals D dash minus clear cover CC minus 5/2. Load causing two-way shear. WP dash. WP dash equals W by L squared into L squared minus B dash squared. Factored two-way shear load. WPU dash. WPU dash equals 1.5 times WP dash, where the nominal shear stress calculated on this basis shall not exceed Ks into tau C. Tau V equals WPU dash upon 4 into B dash into D dash, where Ks equals 0.5 plus beta C, but not greater than 1. Beta C equals ratio of short side to long side of column section, and tau C equals 0.25 times square root FCK.
For complete course and step-by-step illustration, please subscribe full course on Structural Analysis and Design app. Also subscribe YouTube channel Maatrixx Digital Solutions. Thanks for watching.